FastMCP 3 implements a server-level transform pipeline that modifies tool discovery and execution through composable middleware patterns. The framework's CodeMode transform introduces an abstraction layer that wraps existing tool functions, exposing meta tools for dynamic discovery and sandboxed execution while preserving the original tool implementations. We are about to examine how a FastMCP server initializes with the CodeMode, transform, and registers two arithmetic tools using decorator-based registration. The configuration demonstrates the foundational setup, where tools are automatically wrapped by the transform pipeline, altering their presentation to clients while maintaining the underlying function implementations. From FastMCP, import FastMCP. From FastMCP experimental transforms CodeMode, import CodeMode. MCP equals FastMCP server, transforms equals CodeMode. At MCP, tool. Def ags, int y, int. Add two numbers. Return x plus y. At MCP, tool. Def multiplex, int y, int. Multiply two numbers. Return xy. This code demonstrates the foundational setup of FastMCP with CodeMode, a transform that changes how tools are exposed to clients. The CodeMode transform wraps the server's tools, replacing direct tool access with meta tools for discovery and code execution. When a client connects, instead of seeing add and multiply directly, it sees discovery tools like search and get schema that enable on-demand exploration of available functionality. The pattern here prioritizes token efficiency and scalability. By hiding tools behind a discovery layer, the system avoids flooding the client with unnecessary tool definitions up front. This is particularly valuable for large tool catalogs where exposing everything immediately would be wasteful. The three-stage discovery flow, search, inspect schemas, execute minimizes context usage while maintaining flexibility. The trade-off is additional round trips, but for complex systems, this staged approach often yields better results than overwhelming the client with unused tool details. The @MCP tool decorator handles the heavy lifting of tool registration, automatically deriving names, descriptions, and schemas from function signatures. This declarative approach keeps the code clean while ensuring proper validation and error handling. The CodeMode transform then intercepts these tools, presenting them through its discovery interface rather than exposing them directly. This architecture allows the same tool implementations to serve both traditional and CodeMode clients, with the transform layer handling the presentation differences. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which serves as the base class for creating MCP model context protocol servers. This import enables the creation of server instances that can handle tool registration, component transformation, and client interactions through the MCP protocol. From FastMCP experimental transforms CodeMode, import CodeMode. Imports the CodeMode class from the FastMCP experimental transforms module, enabling code transformation capabilities in this context. MCP equals FastMCP server, transforms equals CodeMode. Creates a FastMCP server instance labeled server with a single transform in its pipeline. The CodeMode transform will process components as they flow through this server, modifying them according to its implementation before they reach clients. The server identifier, server, appears in protocol handshakes, but doesn't control operational behavior. It simply helps clients identify this specific server instance. At MCP, tool. Def ags, int y, int. Add two numbers. Decorates the add function as an MCP tool, making it discoverable and callable through the model context protocol. The decorator automatically registers the function with FastMCP, using the function name add as the tool identifier and the docstring add2numbers. As its description, type annotations x, int, y, int define the input-output schema for validation, ensuring the tool expects 2 integers and returns an integer. Return x plus y returns the sum of variables x and y. At MCP tool, def multiplix int y int multiply 2 numbers. Defines a function named multiply that takes 2 integer parameters x and y and returns an integer. The @MCP tool decorator registers this function as a tool in the FastMCP framework, automatically using the function name as the tool name and the docstring as the tool description. The type annotations indicate the function expects integers as input and returns an integer. Return xy returns the product of variables x and y. The CodeMode transform in FastMCP3 introduces a discovery layer that abstracts direct tool access, replacing it with meta-tools like search and get schema. This setup prioritizes token efficiency by staging tool exploration, clients first search, then inspect schemas, and finally execute, rather than exposing all tools up front. The @MCP tool decorator streamlines registration, auto-generating tool metadata from function signatures, while the transform pipeline ensures these tools are presented through the discovery interface. The trade-off is additional round trips, but for large tool catalogs, this staged approach optimizes context usage. The architecture maintains flexibility by allowing the same tool implementations to serve both traditional and CodeMode clients, with the transform layer handling presentation differences.
The decorator whispers the tool's name into existence, then dissolves into the function's shadow.